Okay, seems like we're live now.
Yeah, hi, good evening, everyone. How are you all?
Hey, just let me actually open up the chat here.
Hey, guys, can you hear us? Can I have a confirmation in the chat, guys? If you can actually hear us.
So, how many people do we have? Okay, so hello everyone. Just a sec.
So,
Good
Gopal,
evening,
I see
Suresh.
around like
Good
50,
evening. Yeah. Hello,
50
hello
people, right?
Jitendra.
And
Hello
more.
Vikas. Hello, hello everyone.
Let me
I'm
also
good.
open the chat. Okay, so guys, can you hear us? I guess that is we are fine. How are you? Great. Let me just check. Okay, guys, okay, great. Thank you for the confirmation. So yeah, so first of all, welcome to Let's Upgrade, one more essential program, and this time something new we have for you all, and that is TensorFlow.js. That is how to actually take the power of JavaScript, right, beyond just a web development language and towards using it into something called as machine learning, right? So that is what we are going to learn, and it's going to be a 5 day session, and Gopal is going to be the, you can say, the professional who is going to teach you and make JavaScript in machine learning a piece of cake for you guys, right? So I am here to just take you to a tour of how the program is going to be and what all things you have to do to make sure that you are completing the program successfully and getting the most out of it and are getting certified. Just let me just quickly pull your chat out in the mobile so I can actually see you side. Just a minute. Yeah, great. Right. So yeah, hi Jitendra, hi Nandini. Okay, so a few familiar names. Right. So let's get started. Lord, let's get started, guys. Okay. So first of all, the very important, see, there are only just 3-4 steps which you have to understand to make sure that you are able to complete this program successful. The first thing, the most important thing is to go and register for this program, right? So if you guys have not registered, you have to just go and register for the program. The link is given in the chat, and if I'm not able to say this, I'll just ask my team to just go and pin it in the chat. So the very first thing which you guys have to do is, if you are not registered for the program, the first thing you have to go on the website and go and register. The message is now pinned in the chat. The very first step, do that. Right now, the second thing, now once you have registered, right, all you have to do is daily, like it is going to be a 5 day class. Every day at 6:30 we are going to meet right here, the same YouTube platform, and same timing, 6:30 to 7:30. We are going to learn about TensorFlow, right? So 5 days daily you have to come live and attend the session and learn what we are teaching. As such, there are not going to be any assignments which you have to complete, but at the end of the program, right, you are going to build one small project and implement whatever you have learned throughout this course to build that one project in TensorFlow, right? So that is very important for you, so make sure that you are attending. So now let me just pull my screen up. So yeah, so everyone, right, everyone would be able to see one community group which you have to join. If you have not joined yet, I'll just also quickly put the link in the chat for you guys, so you can just go and join if you have not joined yet. Okay, so now let's understand the steps, right? As you can see, just give me a confirmation if the text is visible for everyone in the chat. So a 4 to 5 steps process. I'm just waiting for just 2 seconds, 2 3 seconds to get your final confirmation. Okay, great. So yeah, so first thing, as I mentioned, you have to go and register for this program. Second, you have to attend the class daily for 3 days. If you attend all the 3 days, right, you have to give a small exam. Okay, so we know that yes, you've actually attended and actually understood what is TensorFlow and what it's a small MCQ exam. If you pass the exam, okay, if you pass the exam, you are going to get a certificate which is going to be available in a profile, and you can download it. I'll just take you to a tour of the whole website very quick before we start with the session, right? So this is how you will land on, you can say, okay. So this is the Let's Upgrade website, okay, where you go. If you're not enrolled for the program, all you have to go and do is go into the TensorFlow program and go and enroll yourself. Okay, you can check the curriculum and everything. It is right here what you're going to learn, right here, how your certificate is going to look like. The certificate is going to come with a NSCDC affiliation, which is a government affiliation, provided you complete the program successfully and complete the exam. Okay, that is very mandatory, as I mentioned. Now, how you can go and see your certifications and exams is your exams will come right in this portal when you go in the my exams, and your certificates are going to come in the my certificate section, right? So this is how you can go and check your exam, and you will see the exam once you have completed the program. Okay, are going to come in this certificate exam section, and certificates like this will appear here, which you can go and download. Right, soft copies will come in this, and you can see the exams right here. Till this, are you guys clear? Are you guys clear till this, till now? Any doubts till now about how to attend the program and how to complete the program? Any doubts? Any doubts, guys? Just let me just put it. Knowledge media, it is a 5 days course. It's not a 3 days course. Like TensorFlow is a kind of a lengthy topic to cover. It 3 days will not understand. So we are keeping it for 5 days for a change to make sure that you get the maximum benefit out of it. Okay, so this is one thing. Clear. Great. So make sure that you know the whole process about the program before you start with it. Now, one more important thing: if you have any friends, right? If you have any friends who you want to join, because this is a free program, right? It is completely free for you. All you have to do is go to this refer section, refer and earn, and share your referral link to as many students, as many friends as you can, and that will not only just get your friends along with you into the group, but also you will stand a chance to win some amazing swags, gifts, and vouchers from Let's Upgrade. So every month we have this giveaway and leaderboard. Now you can see Shahul is leading the leaderboard with 763 referrals. So if you want to be one of those, you can just go ahead and bring your friends. It's completely free of cost for you. Vaishnavi, currently that 200 LU coins thing is not being made mandatory, but if you want to earn LU coins also, it's completely easy. All you have to go and share your referral, and as your friends join the program, you get the LU coins, right? And so that's basically it about how to go and get started with the program. So I'll take this time to bring forward Gopal, and he is going to take it forward from here. So yeah, hi Gopal sir.
Hello, Prasad. How are you?
I'm all good, sir. How are you?
I'm doing fine. So,
Great.
okay.
Yes.
Is
We
it
can totally
compulsory?
go ahead.
Yeah. So I don't have any
Right.
experience
So I'll
in
just
ML,
take it
but I
over to
know
you.
JS. Can I still be able to understand? Yeah, definitely you will. Don't worry, Jitendra. Okay. Like Programming is nothing but a language to communicate, like to represent the set of instructions. I would say, like, when it comes to machine learning, or deep, like, it will be more precise to deep learning. Okay, like we will learn, like, TensorFlow is a deep learning library, not a machine learning library. But deep learning is a sub part or a subclass or submodel of a machine learning. Okay, so we will be talking about those machine learning systems here, which we will going to incorporate in our deep learning models. But the thing is, like, definitely, if you do have the understanding of a deep learning concept, and like JavaScript, like, and like in this case, like, this is the very first time I'm also teaching JavaScript here. The very first time. Yeah, I have coded in the JavaScript, in my previous projects, and I also code in JavaScript, but it's the very first time when I'm teaching in JavaScript. Okay, so not an issue at all. So is it compulsory for that? Okay, so how many questions are there for? I don't know. I need previous knowledge about Python? No, you don't need, like, it. This session will be all about JavaScript, so no Python needed here. Let me first share my screen with you guys. Okay. Mm-mm-mm. Okay. Okay. So I don't have any. Okay, I think, do I need previous? Okay, I understand TensorFlow and Python, but no idea of JS. I hope I can follow. Definitely, Hillary, you can follow along with the TensorFlow if you have the understanding of TensorFlow in Python. But this session will be all about Python plus, no, not Python, sorry, but machine learning plus JavaScript. How exactly you can basically incorporate both of these two domains into one. Okay, so now let's not waste any more second, and let's hop on to the main topic, which is machine learning or deep learning in general. So just out of the blue, I would like to know, like, how many of you have taken my previous sessions here? Okay, how many of you have taken my previous sessions? So this will be about machine learning systems with brain analogy. I will gonna come back to it. Why am I, even putting it here? Okay, so this session will be all about this particular topic. So yeah, so I actually ask you a question here. How many of you have taken my sessions before? Like here, like, how many of you are seeing me for the very second time, or like maybe the third time, or like, is there anyone like who has already seen me before? No, no, not me. Currently, I'm learning data sciences TensorFlow.JS. Is any of, yeah, definitely it is. It will be in use. Okay, so I will gonna come back to it. Why exactly the machine learning and JS actually makes a best. Hi to all the students like me. First session, we are using JavaScript instead of JavaScript. What do you mean by that? First time. Okay, that is totally fine. So like people okay, so people are asking me right now in the chat, like, why exactly and why in the first place we are using JavaScript, where the machine learning framework is only for the famous for the Python language here. So the very simple reason for that, like, you must have used machine learning or AI in your smartphone applications. Well, when it comes to launching or deploying your application onto the like onto into the productions with the devices that you are holding right now, like maybe your desktop, maybe your like laptop, or maybe smartphone in this case. Well, it actually becomes easier when you have a JavaScript loaded model. The reason is, you can run a JavaScript code like on your web with the help of now we have technologies like Node.js along with the Express. You can definitely do it. And apart from that, like, you can also run those code, like run that code on Android and iOS devices too, with the help of React.js and React Native and what you don't have. So like, JavaScript is something that if you learn once, you can literally implement or literally productionize your entire code base across many platforms, like be it desktop, be it laptop, be it smartphone, or like smartphone, like we only have a smartphone. Like, we also have wearables, but we are not getting into that right now. Okay, wearables like smartwatches. And like in that case, that is where it actually comes handy, like, because Python is not so much production friendly, but your JavaScript, like, you can literally deploy your full-fledged applications on, like, on your smart, like, we will definitely gonna develop one, like in our last chapter, like in our last session, how exactly you can make a smart camera with the help of like, and like, you can literally build it on, like, both on either on iOS or either on Android. But first, you need to understand about what exactly the machine learning is, and what exactly the deep learning will be all about, because TensorFlow.js and TensorFlow itself is a deep learning library. And your deep learning is inspired by your human brain. Your human brain analogy, like we need to make some connections, like how exactly your human brain actually works, and how exactly it actually takes input and processes it, and gives you an output. So we will gonna study about all of this. Don't worry, like it might be somewhat new to you. Like don't consider it as intimidating, because sometimes people like mistake it something new to as something intimidating, but it is not the case. It is totally new to you if you have never studied machine learning plus JavaScript, either of those. So will this be cool? Okay. Will this be helpful? Yeah, definitely. This course will be helpful to like web developers too. Definitely, they will be able to integrate or incorporate those machine learning techniques in their web, in their websites. And JavaScript is the evolving in recent years as React, Vue, Next, Angular, and it is easy to learn. So, yeah, definitely. We are using JavaScript instead of Netflix, Amazon, Spotify, Instagram. All are using JavaScript. Yeah, Raj, definitely agreed. But even before getting into the, like this is my rationale for making you understand about why we need to learn about JavaScript. JavaScript is the language for web, and not only the web. Like now, I'm literally taking over many devices as well right now. Like your smartphone applications are also somewhat being run by like JavaScript libraries. Like React Native is there, and again, like it's really amazing. Okay, so let's start with the machine learning analogy, and like how exactly it actually will gonna work, and why do we need to understand machine learning. Like I can actually just start off with like what exactly a regression is, classification is, but it will not gonna make any sense. First, we need to understand what exactly the machine learning is, why do we need it, what exactly your machine learning systems are, and your brain analogy, like your brain, how exactly your brain analogy actually works when it comes to deep learning. So we will going to link this particular section with the deep learning. Okay, so now let's start, shall we? We should. Okay, so this is your machine learning systems. So what exactly they are? So let's say, like in your traditional programming approach, when you have let's say you have a task is to identify if an email is spam or not a spam. Assume it, like this is something that you need to figure out. And how exactly do you have an email, in which format? Like you have an email, and like you have, like you have subject here, right? You have a subject here, and you have the body of that email. Body basically mean whatever the the what do we say, sender has sent you, right? Body of email. Okay. Sir, I'm developing. No, I cannot. Sorry. Okay. So this is like, let's say in this subject. Okay. In this subject, you have words like free, prince, lottery. Okay. And let's say like you. Okay. Let's say $1 million. Okay. So let's say you actually found these words in your subject. Okay, sometimes they could be even like in this case it's an alphabet, right? It's an alphabet, so these could be alphabets too. So in this case, like you found these words in your subject, and you declare them as a spam. Like whenever I encounter these specific words, especially in this case, like it is on all in capital case, capital case, capital case, and somewhat like again a gibberish value. So whenever I actually happen to encounter these words in my email subject, okay, I will gonna declare them as a spam. Else, okay, so let me actually write a pseudo code here. Okay, so what exactly it will be? Can you join the dark theme? Okay, so do you want me to like, guys, do you want me to change the dark theme? Like just tell me, just let me know. Is it better, or like was the earlier one the better one? Which one is better? Just tell me. Okay, just let me know. Okay, and let's say for this one, and now what exactly the problem here could be. So in this case, like we had a few words. Okay, like we had free, we had you, we had prince, we had $1 million, something like that. And somehow you flagged these words. Okay, flagged words. Flagged basically means like you are marking them as a spam. Okay, and now what happens? Like, okay, somehow the fraudster actually happened to figure it out. Like, okay, these words have been marked by you. Why don't I actually add something new? So instead of prince, he started to add like now your words queen. Okay, like diamond. Okay, I like or like sale, something like that, or like discount. So how many words? So how many words? Okay, people are actually saying like dark will be okay. I just changed to dark. Okay, so how many words? How many words will you going to flag? Can anyone here answer me this? Like, how many words will you going to flag? Anyone? Anyone? Like, the number of words will be infinite, if you ask me. There will be no end to that. Froster will just gonna figure it out what words you have flagged here, and will just gonna send you over and over. Okay, so what we can do here, that's where you use a technique called approximation method. Let me tell you what exactly it is. Approximation method, or sometimes even referred as or universal approximation theorem. Okay, so what exactly it is? Let's say again, I represent here. Sorry, sorry, just a sec. Okay, let's say I represent here. Oh, my bad. Like these words. Okay, and here, let's say I represent spam words as follows: spam emails and non-spam emails with green. Okay, so what if somehow, like this is my task? Let's understand the task here. Okay, somehow, what if we project spam and non-spam emails on an XY plane? Okay, like we will gonna understand about like how exactly we can actually vectorize all of this. It's totally a different topic, but assume you somehow converted those emails into a numerical format, and now you have projected those spam and non-spam emails onto an XY plane. And now what you can do here, let's see. And now what if we actually come up with a line as follows, which separates these two by having a small error. Okay, let me come back here, like this and this. Okay, these are your here, these are your errors. Okay, what do I mean by that? So what if we somehow project these spammy and non-spammy emails on your XY plane, and now we are separating these spam and non-spam emails with the help of an XY, with the help of a straight line. And we all know the equation of straight line. What exactly it is? Y is equals to mx plus c. It's not a big deal, right? So this case is something like, in this case, what we are trying to perform here is universal approx. We are trying to approximate a prediction or a data point here. Like 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 whenever something actually comes in, like based on the subject, we will going to declare like if it should reside on this side or on this side. That is the machine learning is all about, the curve fitting between the data. That's it, most of the times, obviously. Okay, so this is your machine learning. That is machine learning actually solves the problem with, like instead of using it manually, we try to automate it, we try to approximate it with the help of machine learning techniques. All right, is it clear to everyone? I hope so. If not, just let me know. Okay, and now what we will gonna do here, let's see. Okay, and let's see. So like, okay, now we know, like, okay, like this was your spam and not a spam, but what kind of machine learning systems do we have here? Okay, so let's see. So up until now, how exactly a machine learning system learns? How exactly a machine learning system learns? Let's see. A machine learning system learns majorly across three categories. First one is supervised machine learning system. Second is unsupervised. And third one we have here is reinforcement learning. And then we have semi-supervised as well. Then we have self-supervised as well. Like there's, like, I wouldn't say like there's no end, but there are like a lot of learning systems now, especially in 2022. Okay, but we will be broadly will be speaking about these two specifically here. Okay, so now let's see what exactly your supervised machine learning system is. Supervised ML system. What exactly this is all about? Let's say you have like not okay. Let's say you have okay an orange. Uh, let's say you have an orange here. Okay, I think I should actually fill this up. Okay, just a sec. Damn it. Sorry. Okay. Let's say you have an orange here. Like this is an orange, right? And like actually orange will be really simple example. Let's say you have a cat. Cat example always works just fine. A cat, like how exactly a cat looks? Like it has a pointy ears, right? And it has some what grumpy face, whiskers are there, eyes are there, right? And we have whiskers, we have eyes, right? And we have some smile here. Okay, assume it like this is a cat, or assume it like it, I'm just telling you it's a cat. And what you can see here, like how exactly did you determine if it was a cat or not? So what features do you see here? Features of a cat, what exactly they are? So just go here. Features will be pointy ears, okay, triangular nose, all right, and long whiskers, or maybe like a smiley face. Assume it like smiley face. These are the features, and these features represents that like what exactly? A cat. So this cat will be referred as a label or a class. Okay, is it clear? Okay, so now what we do, basically what we do in supervised machine learning system and supervised ML system, we try to come up with come up just a sec come up with a machine learning model, with a model, with a model or a mathematical representation which satisfies feature and label pairs. That's it. Okay, so what do I mean by that? Like we have got features here. Okay, let's say x1, x2, x3, x4. Okay, and these four features constitute a cat. Like, this x1 could be your pointy ears, nose, height, smile, anything. And this can be represented as y. Okay, so now what we have, like these are called features. Like you need to understand this representation, because when we will be coding this out, you need to have this knowledge. Otherwise, like everything will be done. Okay, like just gonna go over your head. So you may not like that. So that is why. Okay, so these are called features, or also independent variables. Okay, and in this case, this is called a label or a dependent variable. Oh, okay. I just explained what exactly the y means here. All right. So this is called an independent variable and dependent variable. So what we do basically, we have this, we called here is like a D data set, and we have x1, x2, x3, x4, xn, comma, not comma, along with y, I. Okay, so this kind of system is referred as a supervised machine learning system. Supervised machine learning system. I should not be this much lazy. So supervised ML system. All right, and now, okay, examples of supervised machine learning systems. बहुत लिखना पड़ता है यार. How many of you understands Hindi? Okay. The first one which we will gonna understand here is regression, because this is the very basics of your machine learning, your supervised learning system, and classification. Okay. So like these are actually important, guys. So that is why you need to have this. So again, since it's actually a supervised one, so for the regression, what exactly it is? When we have when we have features as x1, x2, x3, you can have n features here, xn. Okay, and based on and these features constitute a y. Okay, and you can even represent this function as fx given fx given x. Okay, where fx belongs to R. I will gonna come back to it what exactly it is. Okay, so in order to put a one-liner here for the regression, we can actually represent regression as follows. When we have a task to predict a continuous value, based on feature set. Okay, so is it clear to everyone what exactly it is, what exactly the regression is here? So let me ask you here, I would like to know which one is, like, if you have understood it or not. Like let me, if actually if it is comprehensible or not to you now right now. So what the hell, sorry, like sometimes actually okay, so all right, so we have this here, we have this xy plane. Don't worry guys, I won't be speaking Hindi here, just ask that question out of the blue. Okay, because I won't be able to explain this in Hindi better than I can actually explain it in English. So sorry. Okay, this is how it is. Honestly, I cannot explain it better in Hindi rather than in English. So I'm gonna stick with the English here. All right. So right now, like this is your continuous. Like I will gonna come back to it. How exactly? This is your continuous graph, and this is your discrete graph, or sometimes this is also known as a non-discrete. Like people actually use fancy terminologies all the time, so sometimes they are also call it non-discrete. Okay, so what exactly is your continuous graph? So this is your continuous graph. Okay, so we have a y here and we have an x, and for this one this is your y and this is again your x here. And let's say like, and this is your discrete graph. So your continuous, like it doesn't loosen up its continuity. Okay, so when I ask you, like let me actually take a test here. Okay, let's say I have here number from 1 to 5 and 1.0 to 5.0. My question is here, how many numbers do you see for, let's actually call equation 1, or interval 1 and interval 2. Let's call this interval 1 and interval 2. How many numbers do you see in each interval? I'm giving you 30 seconds. Answer. And how exactly? Just answer this. Don't worry, guys. I won't be speaking Hindi. As I mentioned, as I just told you, I won't be even able to make you understand in Hindi because I don't even study this subject in Hindi, so it won't be possible for me either. So don't worry about that. Come on. How many numbers do you see in this interval and in this interval? Interval number 1 and interval number 2. Interval number 2. How many numbers do you see? First one is just 5 numbers, and while second one is infinite. Exactly. Exactly. That is the answer which I was looking for. First one has only 5 discrete values. And the second one, the second interval, has infinite values. How exactly so? So like even between 1.0 to 2.0, there are infinite values. If people are not getting it, like just you need to study about non-terminal values. When I say 1 by 3, it is a non-terminal value. Okay, so I can literally represent this 1.0 like 1.0000001. I can just go on and on. There is no end to it. Therefore, the answer to the second interval, the number of the number you see in the second interval will be infinite. I'm sorry. Okay, and for the first one, obviously 5. So in this case, this interval won't represent a regression task, whereas the second interval will gonna represent a regression task. Why? Because regression is something that where we actually predict a continuous value. Okay, so in this case, when you have such graph for your y, of course, this is your regression. Just remember this. Okay, okay. And now let's come back to the classification. Since we actually studied about, like I wrote here 2 types of, like example for machine learning systems, supervised machine learning systems. So machine learning system, not systems. Okay, so like the first one was your regression. The second one is your classification. And as the name suggests, we classify an entity based on features, right? Okay. So like the cat and dog example, like it's the good old example, or good, so old school example. How exactly? So let's say you have a picture of a cat. Okay, like I will not gonna draw a cat here, of course. Like I just suck at, you know, cat. Okay, and let me cat versus dog. Let me actually have it as this. Okay, so let's try to understand this, like based on this. So this is your, like, you can consider this example as a classification one. Like you can see for this one, like you have saggy ears, whereas cat has pointy ears. Like cat is somewhat looking dominating right now, obviously intimidating, like literally wants to kill you right away. But whereas the dog is literally admiring you as a god or something. Okay, and you can see the expression as well. Yeah, the cat has smaller nose, dog has bigger nose, different kind of, like maybe the mouth shape, obviously the stature of each animal. Okay, based on these features, okay, what we can determine, we can perform a classification task. Like our machine learning system will going to determine, or will going to classify, if an image is of a dog or of a cat. That is your classification, guys. What did you ask? Kana Gala Lakshmi, I don't understand. What did you Kana Gala Lakshmi? I hope I'm pronouncing your name right. Okay. Okay. So I don't know what exactly did you ask. Okay. All right. So this is your classification task. So what we can write here, based on features, we classify between two, or I would say one or more entities. That's it. That is your classification task here. Is it clear to everyone or not? Just let me know. Okay, if not, just let me know. All right. So that was your pretty straightforward supervised machine learning system. Now coming to your unsupervised machine learning system, what exactly it is. Let's see. So your unsupervised machine learning system. Like the very popular example for this unsupervised machine learning system is your recommendation system. I will gonna come back to it, but let me write it here. Recommendation, you know, system. What exactly it is? So I know, like everyone, like I hope so. Everyone here, I hope that they must have actually visited this website. Must have, right? Okay. So what I'm searching here, let's say, like for this, like I was just looking for these classes recently. Okay, Tug Life Cool classes. Okay, so I don't know what exactly these classes will be, called. Obviously, like these are classes, but don't know the specific, like specific type of it, like what exactly they are. I know they are classes like Tug Life Cool classes. That is totally fine. So now you can see here, based on my activity. Okay, based on what exactly my activity was here, I searched for these Thug Life classes here. Okay, and now I will be recommended, like recommend. I will be recommended. I hope I am pronouncing it right. Okay, and these Thug Life classes, just beneath this, right? Okay, and like I didn't have. Okay, like I will want to come back to it what exactly they are, but you can see, like based on based on based on previous activity. Okay, we are being recommended 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 similar objects. Not only for this one, but what if like let's say for the Netflix. Let's go here for the Netflix. Okay. And when we go into the Netflix, let's say, let's actually go into this one. I actually use, I binge, not binge watch, but let's say I actually use this one. Like I watch a lot of anime. Okay. And like you can see, based on this activity, I am being, like right now, like you can see, I can actually, like they are referring Naruto, and even My Hero Academia and One Punch Man. Like these are the movies, or short films, or maybe like anime series. I'm being I'm being recommended by this Netflix. Why exactly? Just because of my like the previous activity which I made here. All right. So that is the recommendation system. Okay, so how exactly it works? Let's see. Again, come back here. All right. So like I will not gonna come back. Will not just gonna get into the math of it, because it's more relying upon the matrix factorization technique, which I won't be covering here for sure. All right. But I can just simply write here, when we have when we okay when we have insights to derive from features only. That's it. Okay. So what do I mean by the features? So we have only features here. Like what? X1, X2, X3, X4, and Xn. Okay. And these features, like we don't have any labels. Okay. And based on these features, we draw observations and insights. Okay. So in unsupervised machine learning system, you do not have any labels associated with features. I have just given you an example. Like a recommendation system is an example of your, like unsupervised machine learning system here. Is it clear or is it not? Recommendation based on search history. Yeah, you can call it like that. Definitely. Not precisely though. Okay. And classification clear now. So all right, that's great. Last but not the least, which we have here is your reinforcement learning. Okay, what exactly it is? So reinforcement learning, you can understand, or you can comprehend this topic as training a pet. Like let's say you have a dog. Okay, and based on the like based on based on the activity of your dog, you punish the dog or reward the dog. Okay, and your goal here is to maximize the reward, where you try to minimize the punishment. Okay, and you try to maximize the reward based on the behavior you want from the dog. Okay, so let's say like you ask your dog to play dead. So if your dog doesn't do it, you basically imply or do some punishment on him. And if he does, okay, you give him a cookie or something, or a dog biscuit. So you try to maximize the number of cookies, or those number of dog biscuits, in order to make your dog realize, okay, like this is something I need to do over and over in order to make my honor happy. Like, okay, this is something my honor actually wants from me. Okay, so let me just do this only, and I will just not gonna get into this punishment at all, and I would rather increase this reward system here. Okay, so in order to put that entirely into the machine learning scenario, so what we try to do, we try to train an agent with a learning policy where, while I would say, while maximizing its reward. Okay. Okay. All right. Is that clear to everyone? To every one of you? Yes or no? Just let me know. Then we will just gonna like somehow connect this entire thing with the deep learning, because your TensorFlow is your deep learning library, right? So deep learning, what exactly it is? So we somehow completed your machine learning systems, but right now it's all about like the deep learning here. Not so clear. What is not so clear, Hillary? Just let me know. What exactly it is not clear to you? Not clear. So which part is not clear? Just let me know. So even before diving into the deep learning, like it will not just going to make any sense then, because now is the time like when we will be talking about some dendrites and axons and like those sheets, everything. So what exactly which is not clear to any of you guys? Just let me know. I'm waiting here. Training the agent while maximizing the reward. Okay, Hilary. So I guess like here, let's again go back here. So in this case, this dog will be referred as an agent. Okay. And in the training, wherever it actually occurs, will be referred as a system or an ecosystem where this dog will be trained. And this is the reward, like, based on the behavior you want from the dog. Like, you want to play your dog to be dead. Okay. So if your dog actually plays dead, you give him a reward. And you try to maximize that reward over a period of time until actually your dog always does that. Whenever you ask your dog to play dead, he does it. Okay, without a fail. So that is what you are doing with there. So okay, regression. You couldn't understand regression. What do you mean by the, Suresh? Because I think like it's actually a good time, like for the 5 or maybe like till 7:30, because this is all we have right now. I think I can take a Q&A here, and then we can move forward for the deep learning, and maybe like tomorrow's session, because people are actually having problems with regression itself right now. So yeah, what exactly did you not understand in regression, Suresh? Just let me know. And someone is saying recommended based on search history. Okay. I really don't want to get into the matrix factorization right now. Okay, but if you really want to understand that, I wouldn't just call it like, based on only history, because there's a lot of math actually which actually goes into that. And if you get like, it's basically when you try to factorize a metric across, three different matrices, and then you try to fill those values. We have sparse matrices in each of those sections. Okay, user, item, and everything, and that is where we again merge those. So like it is not solely upon the history itself. Okay, like the math is totally different here. Okay. Okay, understood. Thank you so much. One more, explain it, sir, shortly. One more. Okay. So, giving you a simple, straightforward example, what you can see, like another example for regression. Let's see. Like okay, regression example. Let's say, like it's a very straightforward example. Based on area, predict the house price. So how many parameters or variables do you see? First one is the area, and based on the area, what you need to predict is house price. Okay, and now what it will be? This will be my x, and this will be my y. So what I can do here, I can put area and house prices. I'm just calling it HP. Okay, like let's say like you have 2,000 square feet, and which actually is like maybe like $100,000. I know like it won't be justified maybe like, but I'm just making that stuff up. Let's say like 1,500, and based on that like you have let's say $75,000 or something. Okay, so based on these, and these values are your continuous values, right? Like this $100,000 value could be as follows as well. No one is going to stop you. Okay, so when we have a continuous value, a continuous value to predict. Okay, so that's where your regression actually comes in. Uh, okay, in recommendation system, does user behavior comes into the pictures? Definitely it does. Yup. So like let me actually explain what exactly it is. So in like it actually somewhat loosely inspired from the TSNEs and like technique like TSNE and PCA, and in your like in your dimensionality reduction techniques. Like it's actually a good question. So in dimensionality reduction technique, we have a technique called SVD. Like what we try to do here, we try to decompose vectors across different vectors. So what we do like in matrix factorization, like what like I will not be able to get into the full details of it, but I can just tell you like let's say you have three matrices here for the user, for the item, and for like let's say maybe for the rating. Okay, let's say like a user, okay, rates an item, okay, rates an item, I'm just calling it Ri. And again like let's actually call it U1, and this will be your item 1, and this is your rating 1. Again user 2 came in, rates second, like gives a second rating on the item 1. Again user 3 came in, gives the third rating on the item 1 itself. Okay, and now somehow like okay, let's actually like let's actually keep them actually like the similar users, so it actually makes sense. Just just actually just stick with me based on these. Okay, and now what we will gonna do with this? Okay, so item 1 item, but we cannot give more than one rating on an item. So now we have to change the item here. So let's say we have item, let's say 1, and based on that we have a rating 1. Item 2, based on that we have rating 2. Item 3, based on that we have rating 3. And let's say like these items, like and these items and these items all can be represented across a matrix. Like like U can be represented as that, R can be represented in a matrix, and I can also be represented in a matrix. Okay, and these matrices are somewhat a sparse matrices. Okay, your sparse matrices are like when we have lot of like zero values, when we don't have any values to be filled here. These are your sparse matrices. So what we try to do, we try to fill these values. Okay, we try to fill these values. All right. Okay. It's filtered. Okay, yeah. So yeah, so this is something we do actually there. Okay, and then we basically again somehow merge all of these together, and we have a system like matrices. which represents like, okay, this user and this item can actually somewhat relate here. And this is somewhat like, not exactly, you can also see that in Facebook's link prediction task as well. Okay, Facebook back in 2014 or 16, I don't recall it, like they you launched a challenge called, Facebook's recruiting challenge. Okay, where they had around like, user one and something rating one or something. Okay, so they had to determine, based on some nodes and everything, you had to determine like, the link between those users. For example, let's say user one is friends with user two, user three is friends with user two. Okay, and based on this, like based on like, based on this commonality, there are chances like user one and user three could be friends. That is why you usually see like, in your Facebook notifications, do you know this person or not? That is happening because of the link prediction again. Okay, so like people actually use sometimes, link prediction, and we have also that matrix factorization as well. So yeah, it actually literally went to the, like recommendation systems entirely right now. Yeah, like we are pretty much done, because I don't think so like I will be able to complete the entire deep learning or its analogy with the brain and everything. I think this is something we will gonna do in our next topic or next session. So till then, if you do have any questions, then please ask me. Then please do not hesitate to ask them out. I'm here to answer those questions, and yeah, just let me know. Yes, they used to show your yeah, yeah, definitely. They used to show your soulmate. Definitely. Anything else, guys? We are pretty much done for today's session. And next, like in our upcoming session, we're gonna continue with the deep learning and its analogy, then along with the JavaScript. No doubt. So that's great. Okay, I don't think so. We do have any questions now. So yeah, thank you so much again for joining in. Firstly, okay, and for taking out your time and being here for straight 1 hour. Are we going to learn about neural networks? Yes, Anuj. Tomorrow, we will gonna learn about neural networks and its analogy. What are your trainable parameters? What are your untrainable parameters? How do you determine the number of those trainable parameters? Units will be there, neurons will be there, activation functions. How do you make those connections? What are your fully connected layers? We will gonna understand about each of these topics. Like, so don't worry about it. Please recommend read up materials we need here. Yeah, this course has prerequisite. Thanks, Gopal. Wonderful class. Thank you so much. Yeah, like it's actually okay. TensorFlow is already a deep learning library. I tried my best to make it, somewhat keep it as onto the ground as possible. Right? Although people were actually somewhat asking really different, really interesting question. I would say not difficult, because if I would have gotten into those questions details, like this entire session would have been a mess. Okay. What about the Bayesian learning? Yeah, we can like, why exactly you are asking for the Bayesian learning right now? Uh, thank you so much. Okay, for the next. Okay, so people who are asking me for what kind of knowledge they should have, I can only expect here. Like they can have knowledge about linear algebra, somewhat chain rule, and like in your differential calculus, and matrix multiplication. That's it. That's all I need from you, and partial derivation as well. these four topics. So I'm having an error of fitting the model net as value, which is failed to convert a numpy array to tensor. I tried many things, but it is not going anywhere. So please, can you give me a hand? Sure. Okay, I cannot actually, like right now, definitely I cannot help you with that because I don't have your, uh, system and anything. But honestly, I would have helped you, but it is almost impossible to answer this. Okay, here from here. Basic maths, differential calculus, linear algebra, somewhat. Matrix multiplication will be fine, and you are good to go. Okay. How do you handle missing or corrupted data in a data set? Like we have imputation techniques. I guess Raj. We have we have imputation for numerical values. We do have imputations for categorical values, right? The last one, please. Yeah. Chu Nosku Habbakuku. Please ask. What exactly is your question? Basically 12th level partial differential equation. Yeah, you need to understand partial differential equation. Yep. So is there any way to connect with you? No, so sorry, like just go into the community of Let's Upgrade. I am active there, so I might be able to answer you there. Okay. So how do you handle missing or corrupted data? I think I just answered this. uh Please share your LinkedIn, Insta, YouTube. My LinkedIn is Data Guy 404. If people are interested in, like, I can only give my LinkedIn here. Just go here, go on to this one. This is me. That's me. Like Data Guy 404, and you can you can actually Okay, thank you so much. All right, guys, thank you so much for joining in today. And मिलते हैं फिर वापस से कल. Okay, I will be seeing you tomorrow. Where is this time? Where is this place? And where is this same person? Okay, with much more to share with you. And till then, please take care. Bye bye and bye bye. Okay. Yep, we will gonna see those as well. Okay, thank you everyone. Bye bye.